All right, so we want to look at the 5 circled ones here because we want to just kind of review the rules for writing a chemical formula that we learned yesterday. Okay, the first rule is we have to decide whether the compound is ionic or molecular. And in order to do that, all we look for is the presence of a metal at the start of the compound. All right, so for question 21 here, potassium. Is potassium a metal or a non-metal? It's a metal, okay? It's on the far right, or sorry, left-hand side of the staircase, okay? So I write the formula for that. I know it's ionic, so I'm also gonna write its charge. And then it's with carbonate, okay? Carbonate is a polyatomic ion, so I have to go up into my chart of polyatomic ions, okay? It's CO3, and it has a -2 charge. All right, what do I do with the 2 charges? Right, yeah, everybody's got some different symbol for drop and swap. Okay, that's what we got to do. Okay, so I'm going to drop the 1, swap it over here. We don't write 1s, so I don't need to write it there. I also then don't need any brackets because I'm not putting a number beside the 3. Okay, and I bring the 2 down over here. Okay, K2CO3 would be our formula for potassium carbonate. All right, questions on that one? And if there's anything giving you trouble here, make sure you ask, okay? Today's the day to make sure we understand everything. All right, question number 22. I've got lead with a Roman numeral 4 beside it, chloride. So first off, ionic or molecular? It's ionic, lead's a metal, okay? What does the 4 tell me about lead? The charge to use, right? That's the whole reason we put those Roman numerals in there. So I'm gonna write Pb with a 4+ beside it, and chlorine, whose charge is -1. Now that I've got that, now it's just a matter of dropping and swapping. Okay, the 1 goes here, we don't write 1s, the 4 goes here. Good to go on that. How many people have done 24? Okay. All right, so ammonium hydroxide is a bit tricky. It's the first one we've ever done that has 2 polyatomic ions in it. Okay, this is pretty rare because ammonium is the only polyatomic ion on your chart that actually behaves like a metal. It has a positive charge. It's the only one you have on your chart that has a positive charge. Okay, so it's still an ionic compound. So we go NH4, and it's got a +1 charge, and it's with hydroxide, which is OH, which has a -1 charge. So those charges already balanced. Okay, so I don't need to put any numbers, and I don't need to put in any brackets. This compound is already correct the way it's written. Now, had they given me something else, like let's say ammonium sulfate, for example, okay, that's a -2. Now would I have to put brackets in?
Yes.
I would, because the 2 would come over here, and rather than saying NH42, I need to say NH4 2SO4. Okay, those little numbers that are on there, they don't change. We can't change those little numbers. All we can do are add other numbers and brackets. Okay, everybody all right with that idea? Okay. That doesn't come up very often, but in the off chance that it does. Okay, then number 27, dinitrogen pentoxide. Ionic or molecular? Molecular. Okay, we've got 2 nonmetals and prefixes. Prefixes are always a dead giveaway because we don't use prefixes in ionic compounds ever. All right, so we've got dinitrogen, so that means how many nitrogens? 2. Okay, pentaoxide, so oxygen, what's the number? 5. Okay, penta means 5. Okay, tetra is 4. All right, so we got N2O5. And then for number 30, we have another one that's got a Roman numeral, and we have a polyatomic ion. So we know for sure this is ionic, because we would never have Roman numerals in a molecular compound. Okay, so we got manganese, which is Mn, and the 2 tells me the charge is +2, and it's with hydroxide, whose charge is -1. All right, so when I drop and swap, the 1 goes here. We don't write 1s, so that's taken care of. The 2 is going to drop over here. What do I need to put around the OH? Brackets. There's our formula for that. Okay? Everybody with me there? All right. I want you guys to do, circle them in blue now. 31, 32, do those ones, and then we're going to go back to ones where I give you the formula and you write the name, so we can practice both kinds. Okay, so do those 5, okay, and we'll walk through them, and then we'll move back to the other kinds of names. Okay, let's have a look at these ones here. So for number 31, we're back to that only positively charged polyatomic ion that we have, ammonium. Okay, so we have ammonium, NH4, it has a +1 charge. Okay, and we know it's ionic because it's a polyatomic ion. Okay, so it has to be an anionic compound. And it's with carbonate, okay, which is CO3 with a -2 charge. Right, so when I drop and swap, the 1 goes here, so I don't need to do anything there, but the 2 is going to come over here, just like that example I did with sulfate. Okay, so we're going to have NH4, 2, okay, and then CO3 after that. Questions on that one? For number 32, we have aluminum oxide. Is that ionic or molecular? It's ionic. Aluminum's a metal. Okay, so we have Al, and it has a 3+ charge. It's with oxygen, which is a -2, and just simple drop and swap. 2 comes here, 3 goes there, Al2O3. All right, for number 36, okay, we've got silver chromate. Okay, so we got Ag. Is silver a metal?
Yes.
Yes, +1. Okay, and then chromate, CrO3, right? And it's a plus or -2, CrO4, and it's -2. Yeah. Okay. So on this one here, we're going to drop and swap. Okay, the 1 will go here, so we're not going to need brackets. Okay, the 2 will come here. And for number 38, we got chromium 3. So we got a metal with a Roman numeral. What does the Roman numeral tell us about chromium? Its charge, okay, +3. And it's with phosphide, okay, which is a -3. So 3 and 3. That's good. All right, and then number 39, we got cobalt 3 nitrate. All right, so cobalt is CO. The Roman numeral tells me what charge to use for the drop and swap. It's with nitrate, which is a polyatomic ion, okay, that has a -1 charge. All right, so the 1 will go here. We don't write 1s. That's taken care of. This 3 is going to have to go over here, so I'm going to need brackets so that it's not NO33. Okay, so that it's NO3. All right, questions on those? Okay. All right, so I would like you guys to do on this one, 4, 5, 11, 12, 13, and 14. Okay, so let's have you do just the circled ones there, okay, and we'll go over those in a couple of minutes. All right, so for number 4, right, we've got calcium and we've got sulfate. Ionic or molecular? It's ionic. Calcium's a metal. All right, so we follow the ionic naming rules, okay, and we simply write the metal and then the non-metal, in this case sulfate, a polyatomic ion, so this is just going to be calcium sulfate. Okay. And then for number 5, aluminum's a metal, so again we have an ionic compound here, so we're simply going to write the name of the metal, aluminum, right, and it's with bromine, so this is going to be aluminum bromide. Again, no prefixes because it's ionic. Okay, the number doesn't matter there in terms of the name. All right, number 8, pretty common one. You probably just knew the answer to this one without having to think about the rules. Okay, I've got 1 carbon and 1 oxygen, so it's a molecular compound, and I simply write them out in order. So carbon without its name changed, and then a prefix on oxygen for the 2. Okay, carbon dioxide. don't be afraid to ask questions, guys, if there's something you're not understanding here. Okay, for number 11, so we got, this one's tricky. Is this ionic or molecular? Tricky because it starts with nitrogen, doesn't it? Except that that nitrogen is part of a polyatomic ion that we were just looking at before called ammonium. Okay, so this is actually an ionic compound. So this can be a tricky one when you're going from formula to name. Okay, so that's ammonium. Okay, name it like it's the metal because that's what it's behaving as. Anything that's positively charged and at the front, okay, is behaving as a metal. Ammonium is the only polyatomic ion that behaves like a metal. Right, so we have ammonium with chlorine. This is simply ammonium chloride. Okay, now down below it, the reason I circled this one is sometimes people do this. They look at it and they know from their table of polyatomic ions that there's a polyatomic ion with that same formula and it's called sulfate, except that ions can't exist by themselves. Okay, they can only be part of an ionic compound. So that stuff is not actually sulfate. It can be an ion, but it can also be its own compound. Sulfur tetraoxide. Okay, named as a molecular compound. Okay. Number 13, we got another one that has ammonium in it. Okay, so we know that this is an ionic compound because it's got two polyatomic ions in it. Right, so we follow the ionic naming rules, which is write the metal, in this case ammonium, and then write the non-metal, in this case nitrate. Okay, and remember, with polyatomic ions, we don't change their endings back to "ide." Okay, we write them as they appear in the chart. And then for number 14, we've got hydrogen acting as the metal because it's listed first, okay, and it's with a polyatomic ion sulfate, so this stuff is simply going to be hydrogen sulfate. Okay, questions on those? All right, I'm going to have you work on a couple more here, okay, to kind of finish things out. Obviously, we're not going to have time in class to do all 5 of the worksheets that I have on your, or in your booklet, and the keys for which I posted yesterday, okay? Should you practice this at home by yourself? Yes, you should. Okay, I mean, if you're getting every single one of these already, you probably don't need that much practice, okay? But if you're only getting, you know, maybe 3 out of every 5 of them, then you should probably practice a little more. You have the keys there, and of course, you can come and see me for help, okay? Monday at lunch, Wednesday, beginning of lunch, Thursday at lunch, okay? Any of those times, just pop in and ask for some help. We can go over a few more, okay? Just to make sure you understand things. But this is one of those basic skills that we have to have in chemistry. That's when we get to reactions, if you can't write formulas and names, reactions will be nearly impossible. Okay, so we really have to be good at this. All right. The sheet I want. Stop there. Okay. All right. So, well, that wasn't the sheet I wanted. Okay. I want you guys to try 37, 40, 35, 37, 40, 42, 43. Okay, you guys can work on those ones right now. That'll probably take us to close to the end here. We'll go over those before the class is over. Okay, let's have a look at these here, guys. So for number 35, okay, we've got zirconium, which is a metal, okay, with dichromate, which is a polyatomic ion acting as a non-metal. Okay, so this stuff would be named as an ionic compound. That would be zirconium. Dichromate. Okay, this one's kind of weird sometimes for people because they see a prefix in this even though it's an ionic compound, and that's okay. The prefix is part of the name of that polyatomic ion, and we don't change the name. So this is one of those rare cases where there's actually a prefix in an ionic compound, but it's because that polyatomic ion has one in its name. Okay. For number 37, we've got carbon and fluorine. Is this ionic or molecular? It's molecular, right? So this is going to be carbon and then tetrafluoride. Okay, questions on that? Right, and then for number 40, okay, we've got sodium and oxygen together, simple ionic compound. This is just sodium oxide. Okay, no prefixes, nothing. Okay, for the ones that where we have to write the formulas, we got iron 2 hydroxide. So that's ionic because iron is a metal. The Roman numeral tells me to use the 2+ charge. It's with hydroxide, which has a -1 charge. So when I drop and swap, the 1 will go here, and the 2 will go here outside of the brackets. Okay, really important to remember the brackets. Number 43, we got aluminum nitride. Aluminum is a metal, so we write it with its charge. Nitride is a non-metal with its charge. They're 3 and 3. ALN. Okay, they already balance each other out. And for number 4, we got sulfur dioxide. So this is a molecular compound, or sorry, yes, sorry, it's a molecular compound because we got 2 non-metals. Okay, so we got sulfur, there's only 1 because there's no prefix, and 2 oxygens because of the dye. And then lastly, number 50, we got copper 1 bromide. Copper is a metal, so we're looking at an ionic compound. The Roman numeral tells me use the +1 charge. Bromine's a -1. We're looking at CuBr. All right, on Monday, we're going to start talking about properties of compounds and looking at lab report stuff, and then by Wednesday, we'll be doing our first lab. So if everybody can mask up and clear off the top of your desks, I'll come around and spray them, you can wipe them down.